Now this question is given in GATE 2016. Consider the following database schedule with the transactions T1 and T2. So now one schedule is given and they are saying that the transactions in the schedule are T1 and T2, where Ri of Z denotes read operation by transaction Ti on variable Z. Wi of Z denotes a write operation by transaction Ti on variable Z, and Ai denotes the abort by transaction Ti. Which one of the following statements about the abort schedule is true? Now we didn't discuss about abort till now. So what abort means is, whenever a transaction is going to get completed, at the end it will write commit. Now because of some problem, if it wants to stop the transaction as of now and start it at a later point of time, maybe because of the unavailability of some resources or whatever the reason it is, if a transaction thinks that it wants to roll back all whatever it did and then again it wants to do it at a later point in time, then it is going to call abort. So abort means don't commit, that is the meaning of it, right? And restart at a later point of time. So a transaction at the end can either commit saying that I am done and just make all the changes permanent, or it can say abort, which means I am not done and please undo all the changes that I did. That is the meaning of it. Okay. Now whatever definitions we have seen, wherever we had used this commit, you can just do again with abort also, right? Both are equivalent coming to the definitions of recoverable and cascadeless, all this. Okay. Now I'll show you with this example what it really means. Now they have seen, they are giving that there is one schedule with two transactions, T1 and T2. I'm just writing both the transactions in tabular form, and the actions are like this: R2 of X, which means read is going to happen here, right? So R2 on X, and then R1 on X. So read is again going to happen here, R1 on X, and then R2 on Y, which means R2 on Y is going to happen here, and W1 on X. So W1 on X is going to happen here, and then R1 on Y. And then W2 on X. Right? And then A1 and then A2. So A1 is going to abort and then A2 is going to abort here. Right? Now the question is whether, let's go with the options. Now first one is whether it is recoverable or not. So they are asking about the recoverability. Now when do we talk about the recoverability is, if any transaction is reading from some other transaction, then you should wait until that transaction commits, then only you can commit, right? So in this case there is no commit at all, right? So anyway, let's try to analyze this. One more thing is, you have to read something which is written by the other transaction, then only you are going to talk about recoverability. Now in this case, where are the writes and where are the reads? See this. Now T1 is reading directly from the database, because before it read X or T2, before these two reads there are no writes, which means they are directly reading from the database, so no problem with that. And again Y is also being read from the database. Now at this point transaction T1 is writing X, but then transaction T2 is not reading from X, which means transaction T2 is not reading any data which is written by transaction T1. Therefore you cannot apply the definition of recoverability there. Now what does recoverability say? If a transaction is reading some data which is written by other transaction, then you should not commit unless the other one commits, right? But here you are not reading anything that is written by the other one, isn't it? So in this case you are not reading anything, and here also you are not reading anything, right? Therefore between these two transactions, even if one commits or one aborts, that is not going to affect the other one, because no transaction is reading the data which is written by the other one. So there is no need of cascading, or there is no need of both are recoverable. Got it? So you can say that it is definitely recoverable and it is cascadeless. Why? Both are not depending on each other, right? So what can you say? it is not recoverable. It is wrong because S is recoverable. And the second option is saying that S is recoverable but S has cascading aborts. There is no need of cascading here because there is no dependency. Even if one aborts, then other can abort or other can commit. Both can do it independently, right? Therefore, this is wrong. Now, S does not have a cascading abort. Yes, it does not have a cascading abort. What do I mean by this is, even if one transaction is going to abort and roll back, the other one need not abort and roll back. It is up to them, okay? And S is strict. So coming to strict, you can check it here. Now what does strict say? Whenever a transaction is reading or writing something, if the other transaction is also reading or writing the same data item, you cannot do that unless the other one aborts or commits. Now if this action only after this one has either committed or aborted. Wait till then, and then only you are supposed to do it. Earlier we have seen where I told you that you should wait till the other one has to commit. There you can add the definition as if either commit or abort. Now T2 should wait until T1 either aborts or commits, then only T2 should write. That is the meaning of strict, isn't it? So here the strict definition is not followed, therefore S is not strict. The reason is you are trying to write some data before the other one who has already written that data is aborted or committed. That is why it is not strict. Got it? So what is the answer? S does not have a cascading abort, which means it is cascadeless. If it is cascadeless, it is recoverable. That is why you need not specify it separately. Got it? Okay.